Hello, fourth graders. Today I want to show you how you can find equivalent fractions um, and by noticing patterns. Okay, so today your IXL lesson will be titled Patterns of Equivalent Fractions. When you log on to IXL today, you are going to see a set of fractions that looks very similar to this. There's going to be multiple fractions that are separated by an equal sign. There are multiple fractions that are saying that they're equal to each other. And your job is to find the missing numerator or the missing denominator. So here we have an expression that says, or an equation that says, 1/4 is equal to 2/8, which is equal to 3/12, which is also equal to blank 16ths, which is also equal to 5/20. All of these fractions have the same value, okay? And we can show it using pictures. I'm going to use a picture on the top, and I'm going to use a multiplication equation on the bottom. So again, if I'm splitting this into 4 pieces, I know that 1/4 would mean I'm just shading in this top piece, okay? Now I'm going to show 2/8, but I'm going to start by creating the same picture that I just drew. And I'm going to shade in that same piece again. Right now though, so this was 1/4. Right now this picture is split into 4 pieces, but I want it to represent 2/8. So I'm going to split it into a couple more pieces. I'm going to divide this piece in half, and I'm going to divide this piece in half. You can now see that I have 1, 2, 3, 4, 5, 6, 7, 8 eighths shaded in. 2/8 shaded in, but it's broken into 8 pieces. Okay? And I had 1, 2 of those shaded in. But I know that they're equal to each other because I started, before I drew those vertical black lines, we had the same picture. I split into 4ths and I just shaded in 1 piece. So yes, the denominator is getting larger. Yes, we are splitting it into more pieces. However, we're also noticing that our numerator is increasing in size. So now I want to show you how you can identify patterns in equivalent fractions. And we want to see what we notice that is true about the numerator and the denominator. So I'm going to start with the denominator. I'm noticing that each time our denominator is increasing by 4. Plus 4, plus 4, plus 4, plus 4. Right? 4 plus 4 is 8, 8 plus 4 is 12, 12 plus 4 is 16, and 16 plus 4 is 20. I also want to look for patterns on the numerator. That's increasing by 1, by 1, by 1, and by 1. So I have 1, 2, 3, blank 5. Well, I know that 4 is between 3 and 5, and it fits the pattern. 3 plus 1 is 4, and 4 plus 1 is 5. So all of these fractions are equivalent to each other. Okay, so I showed you how we can use a fraction model and a picture to illustrate that we have equivalent fractions. Down on this bottom example, we're going to do the same thing. We're going to find equivalent fractions by identifying patterns and then mathematically proving it using multiplication. So again, I'm noticing that on my numerator, it looks like I'm just increasing by 1 each time. 1, 2, 3, 4, 5. We're getting larger by 1. But I'm noticing our denominator here is not increasing by 4 like we did in our first example. This time it's increasing by 8. 8 plus 8 is 16. 16 plus 8 is 24. 24 plus 8 is 32. And 32 plus 8 is 40. So now let's take some time to mathematically prove that these fractions are equal. So this is saying that 1/8 is also equal to 5/40. And I want to prove that to you now. So if you remember from yesterday, when we were finding equivalent fractions, I'm going to erase these plus 8s and give myself a little more room. When we were finding equivalent fractions, oftentimes we set up an equation that looks like, or set up two fractions that are separated by an equal sign. And if you remember from yesterday, the big idea is we need to multiply the numerator and the denominator by the same number. Okay? And we do that because when we have the same number on the top and bottom, 5/5 is equal to 1 whole. And we know that anytime we multiply by 1, we're not changing the value. So now let's see if this is a true equation. Is 1 times 5 equal to 5? Yes. Because I multiplied by 5 on the numerator, I have to multiply by 5 on the denominator. And I want to see, is 8 times 5 40? 5, 10, 15, 20, 25, 30, 35, 40. Yes, it is. So I multiplied the same number on the top and the bottom, and it made a true equation. Let me show you another example. This time we're going to see, is 1/8 equal to 3/24? So I need to ask myself, 1 times what will give me 3? Well, I know that 1 times 3 equals 3. If I multiply by 3 on the numerator, I have to multiply by 3 on the denominator. Same number top and bottom. 1 times 3 is 3. That's a true statement. 8 times 3 is 24. That is also a true statement. We also don't have to start with 1/8 every single time. For example, this time, let's see if these two fractions are equal to each other. Is 2/16 equal to 4/32? Okay. 2 times what will give me 4? I know 2 times 2 is 4. If I multiply by 2 on the numerator, I have to multiply by 2 on the denominator. Same number top and bottom. 16 times 2 is 32, and 2 times 2 is 4. Same number, true statements. So today, as you practice IXL, you're going to be noticing patterns in the equivalent fraction line of fractions. So see what's changing to the numerator, see what's changing in the denominator, notice patterns, and as always, your teachers are here to answer your questions if you have any. Good luck today.